Good afternoon, Year 11. Hope you're all enjoying your Saturday. Bethan, hope you're enjoying Cardiff. Any of you watching the last international Wales match today? I've got my retro Wales rugby shirt on. I don't know if you can tell. Can you see that? Okay, so I said that today I would look at differentiation, show you how to do it. So I'm going to get inside now because it's absolutely freezing and show you how to do it. Okay, so if you're wondering why we differentiate to find the gradient of a curve at a point. So in the past we've found the gradient of a straight line of a linear equation. We know that the gradient from a linear equation is the coefficient of x. That's nice and easy. If we get given a graph, then we know to draw the triangle on and divide the difference in y by the difference in x, which you'll see is reflected in this differentiation in a moment. And then we've also found gradient at points on curves when we've calculated the acceleration from velocity time graphs. So in this instance, at AS level, you are expected, and for additional, you're expected to be able to differentiate, which is find the expression for the gradient of the curve, simply straight from the expression. So to do that, as you can sort of remember, if you remember that when we were finding the gradient of a certain point on the curve, we would draw the line, we would draw the tangent on, and we'd calculate the difference in y, so y and the difference in x. So that looks like y over x. And when we differentiate, what we actually write as our solution is, instead of y over x, dy over dx. Now that d is actually comes from something called delta, which came from something called differentiation from first principles, and we'll have a look at that later on. But this I'm showing you so that you can differentiate very easily, and then also check in the future when it comes to differentiating from first principles that you've done it correctly. So it's very, very straightforward. Here we've got the equation y equals x to the power of 4. To find the expression for the gradient of the curve, okay, we write dy over dx. There's our y over x, difference in y over difference in x. And that's equal to, and what we do is we take the indice for x, which is 4, and we multiply it by x, so 4x, and then we take 1 away from the indice, so it becomes 3. So the gradient of this expression is 4x to the power of 3. So if I was asking you to find the gradient at the point where the x coordinate is 7, you'd simply substitute 7 into x there and do 7 cubed times 4. So the next expression is x squared minus 5x. So we write dy over dx equals, we bring 2 down and multiply it by x, so 2x. And because we've taken away 1, it would become 1, but as you know, we don't really put that there, so I'm going to remove that. So it's just 2x. And 5x, that would actually be to the power of 1. Again, we don't write that, but it is there. So what happens is when we times 5 by 1 and then that becomes 0, anything to the power of 0 is 1. So what is actually happening, if you look up here, is 1 times 5x to the power of 0. Anything to the power of 0 is 1, so the answer is just 5. So essentially, sorry, that should be minus. Essentially, if you ever don't have an indice, it just becomes the coefficient. The next one, we've got y equals 10x squared minus 2x minus 3. So dy dx equals, right, I'm going to bring 2 down, but there's a 10 in front of it. So because I would have times 2 by x, I'm just going to multiply 2 by 10. So 2 times 10 is 20x. And obviously 2 take away 1 is going to be 1, so I don't need to put the 1 there. And here we go, we've got minus 2x. I'm just get rid of the x, minus 2, because we know that anything to the power of 0 is 1. And then this on the end doesn't have a coefficient, it doesn't have an x. So we can't do anything with that, and therefore the derivative of 10x squared minus 2x minus 3 is 20x minus 2. The next one, I've got 4x to the power of 6 minus 2 over x minus 7. So dy over dx equals 6 times 4, 24. I'm going to get rid of 1, so 6 take away 1 is 5x to the power of 5. Now I've got 2 over x. Hopefully, and with a bit of practice, we're going to remember that 1 over x is the same as x to the power of minus 1. Because remember, minus 1, anything to the power of minus 1 means it's reciprocal. So what this is actually saying here is 2x to the power of minus 1. Now when we have 2x to the power of minus 1 and we want to find the derivative of 2x to the power of minus 1, we're going to bring minus 1 down, so that becomes minus 2x, and minus 1 take away 1, Fion, get your number line out, minus 2. So we've got minus 2x minus 2, and again minus 7 we can't do anything with, so we leave it like that. I'll just do one more to finish. So y equals 25x to the power of 4 minus 5 over x to the power of 6 minus 6. And the reason I'm doing these, this tends to be what they look like, especially in the beginning. So 25x to the power of 4 minus 5 over x to the power of 6 minus 6. dy dx, okay, we get into the habit of doing that, you have to write that down. 4 times 25, 100x, we're taking 1 away from the indice, becomes 3. Here we've got minus 5x to the power of 6 divided by x to the power of 6. So what that actually is minus 5x to the power of minus 6. Remember, because it's over x to the power of 6, that over a minus indice would have made it a reciprocal. So we can assume that it's x to the power of minus 6. If we find the derivative of that, minus 6 times minus 5 becomes positive 30x, and again minus 6 take away 1, minus 1. So here is positive 30x minus 7, sorry, I don't know why I said 1, minus 6 take away 1 is minus 7, 30x to the power of minus 7. Okay, and obviously minus 6 we can't do anything with, so we leave it like that. Hopefully that makes sense to you. On Monday morning I'll give you some questions and we'll practice these in class. It's really, really straightforward. Just remember that dy over dx is n x to the power of n minus 1 when x y equals x to the power of n. Okay, what that's saying is when your expression has the power of n, to find the derivative of it, you bring n down, multiply it by x, and then the indice is the original indice minus 1. Enjoy your weekend and I'll see you on Monday. Also, anybody wondering what the music is, Chelsea Cutler, awesome. Go listen to it.